Okay, so actually, I did copy that warm up on accident. I didn't really want you to do that one. I should have started it day 2, but I didn't realize that that first page was a warm up when I was printing these. So, properties of limits. There are several properties of limits that we must know that will help us be able to solve problems. So, for these limit laws that we have here, they are saying that the limit as x approaches c of f of x equals L. And the limit as x approaches c of g of x equals M. So this is the answer to the f of x, and this is the answer to the g of x here. So the sum rule just tells us that if I have the limit as x approaches c of f of x plus g of x, then our limit for f is L, and our limit for g is M. So my answer is just going to be L plus M. This just means you can break limits apart if things are separated by a plus sign. The difference rule is basically the same, except for you've got a subtraction symbol in between. So if you have a plus or a minus sign in between two expressions, you can just take those limits separately and then either add or subtract their answers back together, which makes it much easier if you're dealing with more like two complex things. You could look at them separately and then put that together at the end. The constant multiple rule, sometimes you may even see that like called a scalar multiple rule, is if you're multiplying some number k by your function f of x, then your answer is going to be that number times whatever L is for that. So if you have just like, it has to be a number. It can't be, if it's got a variable with it, then it's a whole different function, and that's going to change things a lot. But if it's just a number, it's just going to be whatever that number is times the limit that you would get if it wasn't there. Product rule tells us if we've got limit of two functions multiplied together, we can just take those limits separately and multiply those answers together, right? So if we have two things multiplied, we can multiply. And the quotient rule is that if two functions are divided, we can just take their limits and divide them, right? The only exception you have here is that M cannot equal 0 in this scenario. Why is that? It's undefined, can't have 0 in the bottom, right? So if you end up with a 0 in the bottom, then this is not going to work because you'll get an undefined answer. The power rule says if we have a function raised to a power, then it's just going to be that limit value raised to that power. And the root rule is very similar as well. If you have a root of a function, then it's just going to be the root of that answer. So basically the operations, pretty much every operation, addition, subtraction, multiplication, division, exponents, square root, or any kind of root, doesn't have to be a square root, all of those are going to produce limits where we can just use those operations between them. Okay, so I haven't really talked about even functions much, so I'm going to skip over that right there. So here's an example of what you will be asked to do in this first problem. I'm going to do it like perfection math. I'm going to use like perfect math expressions to show you exactly what this means. And then after that, we're going to do it short, easy way, right? Because you don't necessarily have to write all this out. So they are telling us, we don't know what f of x is. It's some mystery function. We don't know what g of x is. It's some mystery function. But I do know that the limit as x approaches 2 of f is 5. The limit as x approaches 4 of f is -1. And I know that the limit as x approaches 2 of g is 6. And I know the limit as x approaches 4 of g is 9, right? So if I have something like limit as x approaches 2 of 2 f of x over g of x, then what I'm doing, essentially, if I'm going to use my division property, which tells me I'm doing the limit as x approaches 2 of the top part, 2 f of x, over the limit as x approaches 2 of g of x. And then I also have, I've got this 2 right here that is a scalar multiple. It's just a number being multiplied by f of x. So I could kind of like pull this out here and do 2 times the limit instead. So I could have 2 times the limit as x approaches 2 of f of x over the limit as x approaches 2 of g of x. Now, I told you I'm writing things out that we're not going to write out really after this problem. But what this does is I've used both my constant multiple and my quotient properties, and now, right here, I've just got the limit as x approaches 2 of f of x. What did they tell us the limit as x approaches 2 of f of x is? It is 5. So this is going to be 2 times 5 over, and then right here, I've got the limit as x approaches 2 of g of x. What did they tell us the limit as x approaches 2 of g of x is? 6. So that is going to give me 10 over 6, which reduces to 5/3. Just a note about your AP exam. On the AP exam, on pre-cal, there were some things that we were required to reduce, not really fractions so much, but like they would tell you a specific way you have to leave your answer. On the calculus exam, you could actually leave your answer like this if it's free response, 2 times 5 over 6. You don't have to simplify things. In fact, on some of the more difficult stuff we do, I'm going to tell you not to simplify because you might mess it up and then you'll lose that answer point for that. Now, this is simple enough that I would go ahead and simplify it probably, especially if you need to use that answer again. But just a note about that AP exam there. So now, we don't really want to have to do this every single time, right, to write all of that stuff out, because essentially I could see I'm going to be doing the limit of 2 times whatever the limit of f of x is as x approaches 2. So that's 2 times 5 over the limit of the bottom, which is going to be my 6, right? I don't have to write this out every single time. So if I was doing number 2, I wouldn't write all of that stuff out, although it would, you know, if you were really walking through it mathematically, you would, but you don't have to. So here I've got an addition, so I can take the limit of these two things separately. So I'll be doing the limit as x approaches 2 of g of x. That is 6. And then I've got 3 times, I'm going to take the limit of that f of x. So limit as x approaches 2 of f of x is 5 for that. And so that just gives us 6 plus 15, which is going to give us 21. Okay, questions there? All right, so 3 and 4 are going to be a little bit different because what is our limit approaching? 4. So we are not using the numbers 5 and 6. We'll be using the -1 and the 9 from over here. So if I'm doing this limit, the powers can kind of stay where they're at. Essentially what it's going to end up as is the limit as x approaches 4 of f of x minus 2 squared, right? Actually, well, I'm doing the limit of those two things separately. Should I have to write that out? I think right here. So that limit as x approaches 4 of f of x, they tell us up here it is -1. So that's going to be -1 minus 2 squared. That's -3 squared, which is 9. So 9 will be our answer for number 3. And for 4, I've got square root of g of x plus 4 that I'm taking the limit of from as x approaches 4. So it's going to be the square root of the limit as x approaches 4 of g of x. You could skip writing this if you really wanted to, plus 4. If I wanted, I hesitated there on the last problem. I'm going to write it this way. I could write this as the limit as x approaches 4 of 4 if I want. But there's no variable right there. That's just a constant value, so it's just going to be 4. They tell us here this limit is 9. So I've got the square root of 9 plus 4. That's going to be 3 plus 4, and I will get 7 for that. Okay, questions? All right. Let's talk about limits of composite functions, okay? So composite functions is whenever you're taking one equation and plugging it into the other equation. So that's like our f of g of x stuff. We did some of that in pre-cal, and you do a little bit in Math 3 as well. So it's when you take like your f of x and plug it into your g of x. So if f and g are functions with the following limits, limit as x approaches c of g of x is L, and the limit as x approaches L of f of x equals f of L. Then the limit as x approaches f of g of x is going to be f of the limit as x approaches c of g of x, which is going to be f of L. All right. So essentially what you need to know here is you're taking the limit of the inside part first, right? So you take the limit of that inside part, and then you have to consider f of whatever that value is for that. So limit of inside first. Whenever you're evaluating composite functions, it's sort of the same. Like if I ask you to find f of g of 3, you'd have to do this part first, right? The g of 3 first, and then you would put that into your f. So these can be very simple, and then some of these with graphs are super confusing, and I'm going to try to teach them to you in a manner which you can understand and remember, but they're kind of difficult. All right, so these I think are pretty straightforward. So I've got the limit as x approaches 3 of f of g of x. So these are just graphs. I could use Desmos on this if I want. I haven't taught you how to do direct substitution yet, so should I use a graph? I don't think I want to. So, if you have a continuous, well, I don't know, I'll probably better use a graph. Let's use the graph. I'm going to pull up Desmos over here, because the other way that I'm thinking of doing this for you does a little bit go into what we do tomorrow as well. So if I've got f of x equals 2x minus 1, that's just a line there, and I've got g of x, oops, I'm typing on the wrong thing, g of x equals 1 over x plus 2. Alright, so if I'm doing this problem, I need to do the limit of the inside part first. So I'm thinking of the limit as x approaches 3 of g of x. So I'm going to turn off my f of x here, so I'm just looking at this. I'm looking right here at 3. In fact, I'm going to put an x equals 3 line in so we can see that line. Looking right here at 3, what does it appear that it approaches here? In fact, if I am using the graph, probably about the easiest way is 2.33333, right? How else can I figure out what that value is right there? If I weren't going to use the graph. You could, but it would be more complicated to do it that way. To get 2.3 repeating, I could just plug the number 3 into this, right? That would be 1/3 plus 2, and that gives me 2.3 repeating, right? 2 and 1/3. So you could plug that number in. But we're seeing this part right here is 2.3 repeating. That means that we're doing, so this is 2.3 repeating. So what we'll be doing now is the limit as x approaches 2.3 repeating of our f of x, right? Because this value right here now is getting like plugged in here for this. So whatever you get when you do the inside, it's the value you're approaching over here, which most of the time is just f of that value. We are going to see something weird happen in a second. Let me do 2.3 repeating right here. And we can see here that it looks like if I'm looking at f as we approach 2.3 repeating, it is going to be 3.6 repeating. So we'll get 3.6 repeating. Now, that's using the graph. Essentially, what you're just doing is you're plugging 3 into your G, and then you're plugging that into your F, if everything, with nice continuous functions right here. Now, would we have had an issue if we got 0 in the first part? That would be an issue because if I got a 0 that I got to plug into this, it's going to give me undefined. So there are some times where it gets complicated whenever that happens. But if it's just continuous at the point you're looking at, you're just basically plugging into the inside first and then to the outside. This second one looks like it might be an issue because I've got limit as x approaches 0 of g of f of x, right? But which one do I do first? I do f of x first. Let me go back to my red so I'm consistent here. So that means I'm doing the limit as x approaches 0 of f of x. So that right here, if I change this x equals 0, it's just the y-axis, right? That is going to hit this graph right here at -1. Essentially, it's what you get when you plug in 0, right? So that is -1. Well, that becomes what we're approaching for our g of x, right? So whatever you get as your answer of the inside is what you're approaching here. And for that, let me cut off f, make this g, make this -1, right? Our g of x, as we approach -1, it is +1 for that. So +1 would be our answer. Okay, questions so far?
So, okay, yeah, you could also do that by taking -1 and plugging it into g of x because 1 divided by -1.
Yes, yes. So plugging in is really the same. I'm sort of I hesitated to just plug in because we haven't done that part yet. It's like at the beginning of the next part of the note, so I wanted to use the graph as well. But if we plugging in works sometimes. There are places where plugging in is not going to work because it's going to be like a point of discontinuity where we've got an issue. But as long as it's continuous at those points, just plugging in should work too. Or you could use the graph. All right, now here is where things get a little bit crazy because I have the limit as x approaches 0 of f of g of x. So that means that I'm going to be doing the inside part first, right? The limit as x approaches 0 of g of x. I got to do that part first. So I can think about it with the graph, or I could think about plugging it in. If I think about it with the graph, whenever x approaches 0 right here on my g of x graph, what happens as I approach 0? I get closer and closer and closer to 0, but do I ever touch? No. And in this direction, my values are going to negative infinity. From the right-hand side, positive infinity. What do we say about this limit right here? It does not exist. If the inside limit, if either one of the limits does not exist, the whole thing cannot exist. So we would just have to say that this does not exist, and since it does not exist, then this does not exist either. So that would be our answer for this one. Okay, but there are some other kind of weird things that can sometimes happen. Okay, so we've got here the limit as x approaches 0 of f of h of x. Okay, so we would need to be doing the limit as x approaches 0 of h of x first, right? Limit, use red like I've been doing. Limit as x approaches 0 of the inside first. So for this, h of x is the second graph. What is the limit as x approaches 0 here of h of x? It is negative 1. Okay? Now, if that means the next piece that I'll be doing is I'll be doing the limit as x approaches negative 1 of f of x. Except for there's going to be a catch to this. So whatever you get for your answer of the inside becomes what you approach for the second part. Right? But what do you guys think about that? Limit as x approaches negative 1 of f of x. Okay, we want to say it does not exist. But there's something I did not consider on the other problems that I have to consider here. And we might need to go back and look at that other one. All right, so the correct answer for this is positive infinity. So, this made... I hope I can even teach it to you guys correctly this time. I think I did teach it correctly last year. But at first I was like, this problem's wrong. I looked at these like, this doesn't make sense. This doesn't make any sense. Has to be, does not exist. That's crazy. But positive infinity is the correct answer. Now, if the answer is positive infinity, what does it mean I was doing for this limit?
Approaching from the right.
Approaching from the right. Okay, so here is what happens. If I'm doing the limit of this, I'm going to approach negative 1. Which direction do I approach from? Both directions, right here, for both left and right. The values on this left side are above negative 1, right? The y values. So as I get closer here, those y values, which are about to become my x values in the next part, right? They're coming from above, and this is coming from above. So since from either side, I start with values bigger than negative 1 and get closer to negative 1, I'm approaching from values larger than negative 1, which is the right whenever you are over here. So right here, you're really approaching from the right-hand side. Okay? And so if I do this as I approach from the right-hand side, then I would get positive infinity for this answer. It would have to be both sides are bigger. And I'm going to go back to the last problem we just did to show you why I didn't consider it there. So if we're approaching from above on h of x, that turns into approaching from the right. On f of x. So if I was approaching from below, what do you think it would be? From the left. All right. Now let me go back to I think this problem here, and let me show you why I didn't even worry about it on this problem. Actually, no. This is only going to matter if you're like at a point of discontinuity, right? So whenever I did these problems, I was not at a point of discontinuity in the graph, right? So whenever I looked at 0 over here, as x approaches 0 up. When I did f of x first, it wasn't discontinuous, right? It was just -1. If I was looking at this, it would approach from both sides because one side goes from the left and one side's below, one side's above, so it'd be both sides. But that really doesn't matter because whenever I look at g of x and I look at -1, which is what I have to consider, the graph is continuous there, right? So it doesn't matter whether it's left or right, you get the same answer for that because the graph's continuous. So it's only whenever you end up on that second one being at a discontinuity where left or right matters that it actually affects the problem for that. So we don't have to really consider it if it's continuous. Let's look at another one. Okay. This one is limit as x approaches 0 of f of h of x. So we're going to do the inside first. So we're going to begin by doing the limit as x approaches 0 of our h of x. And what is our limit as x approaches 0 of h of x if we look at this graph? It is 0. Okay? From above or below? Or both? It's above. I'm going to put above over here. Okay? So since both of those come from above, actually, on this one, it's not going to matter, but let's go ahead and make that note, right? So that means what we're doing is the limit as x approaches 0, I'm sorry, yes, still 0, because this 0 comes here, of f of x. So on f of x, does it even really matter whether it's left or right side? Technically, because these are both from above, we are only approaching from the right side. Does it make any difference on this graph? It does not. You're just going to get -1. Yeah, it's only on ones where you have maybe a jump in the graph or a vertical asymptote that it's actually going to matter. But there are some where it does matter for that. So it's not a bad idea just to be in practice. Like when you get this answer, think about whether it's above, below, or both sides. If it's above, that's going to translate to being from the right-hand side. Because technically you would only be looking at the right-hand side of this limit. It just doesn't matter because they're the same. Okay, questions there? All right, here is another one that's kind of weird. This one only gives us one graph. It's asking for f of x. All right, so we're composing the function with itself. So we use the same graph both times. So we would need to take our limit of the inside part first. So we got the limit as x approaches -4 of f of x. And what is the limit as x approaches -4 of f of x? It is -1. It's that open circle right there, but it's fine that it is an open circle, right? Because you can still have a limit at an open circle. I think it should be 4. Okay. Oh yeah, you're counting wrong. Okay, so we've got this point right here. Now, are we approaching from above, below, or both sides? Well, when I say both sides, I mean above and below. It'll be below, right? So if this is below, then that means when we do the next part, we're going to be doing the limit as x approaches -1. If we're approaching from below, do we need to approach from left or right over here? Left. still f of x because we're doing f of x, right?
Whenever you say below, do you mean like below or above the x-axis, or below or above the point?
Below or above the point. That's a good question. Below or above the point. So if they're coming up from below that point on both sides, then that would turn into being from the left. If they are, like on the last problem, if they're above, both sides are like approaching from above the point, then that'll be from the right.
Oh, so eventually it turns into the
Yeah. Yeah. And so here, if I'm looking at the limit as x approaches -1 from the left, what will I get? That is going to be -5. And that'll be my answer there. You can have places, like for example, let's say it didn't do this and it did like this right here. Then right here, it'd still be -1, but it would approach from above and below, which would mean you'd have to approach from both sides here on that. So it could be both sides, in which case we would get does not exist for that. But because these are both from below, then that's left, which does give us an answer, which is -5. Okay? All right, so we have a couple things.